चैनल। आज हम लेसन 4 स्टडी करने वाले हैं। कंबंशन एंड फ्लेम। वी यूज डिफरेंट काइंड ऑफ फ्यूल फॉर वेरियस पर्पज एट होम इन इंडस्ट्रीज फॉर रनिंग ऑटोमोबाइल्स। कैन यू नेम अ फ्यू फ्यूल्स used in our home? Name a few fuels used in trade and industries. What fuels are used for running automobile? Your list will contain fuel like cordings, wood, coal, charcoal, petrol, diesel, compressed natural gas, etc. You are familiar with the burning of candle. What is the difference between the burning of candles and the burning of the fuel like coal? Maybe you were able to guess right. Candle burn with a flame, whereas coal does not similar. You will find many other materials burning without a flame. Let's study the chemical without a flame. Let us study the chemical purpose of burning and the type of flame produced during the process. What is a combustion? Recall the activity of burning of magnesium ribbon performed in class 7th. We learned that magnesium burned to from magnesium oxide and produce heat and light. We can perform similar activities with a piece of charcoal. Hold a piece with a pair of tongues and bring it near the flame of candle of a Bunsen burner. What do you discern? We find that charcoal burns in air. We know that the coal too burns in air, producing carbon dioxide, heat and light. Chemical purpose in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergo combustion is said to be combustible. It is also called a fuel. The fuel may be solid, liquid or gas. Sometimes light is also given off during combustion, either as a flame or as a glow. In the reaction mentioned above, magnesium and charcoal are combustion substances. We were told that food is fuel for our body. Rightly so, in our body, food is broken down by the reaction with oxygen and heat is produced. We learned that in class 7th. Collect some material like straw, matchstick, kerosene oil, paper, iron nail, stone pipes, glass, etc. The supervision of your teacher try to burn each of these material one by one. If combustions take place, mark the material combustible, otherwise mark it non-combustible. Can you name some more substances which are combustible? You can add those to table. Let us investigate in condition under which combustion take place. Be careful while handling. Fix a lighting candle on a table. Put a glass chimney over the candles and rest on a few wooden blocks in such a way that the air can enter them. Chimney, observe what happens to flame. Now remove the blocks and let the chimney rest on the table. Again observe the flame. Finally put a glass plate over the chimney. What the flame again? What happens in the three cases? Does the flame flickers off? Does it flicker and give smoke? Does it burn? Unaffected, can you infer anything at all about the role played by air in the process of burning? We find that for combustion, air is necessary. The candle burns freely in case when air can enter the chimney from below. In case when air does not enter the chimney from below, the flame flickers and produces smoke. In case the flame finally goes off because the air is not available. We have read that the sun produces its own heat and light. It also some kind of combustion. In the sun, heat and light are produced by nuclear reactions. You will learn about this process in higher class. Place a piece of burning wood or charcoal, an iron plate or tawa. Cover it with a glass jar or a tumbler, transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Can you think of the reason why it stopped burning? You might have heard that when the cloth of persons catch fire, the person it's covered with a blanket to extinction fire. Can you guess why? Now recall some of your experience. Does a matchstick burn by itself? How does it burn? You must have had an experience of burning a piece of paper. Does it burn when a burning matchsticks in brought near it? Can you burn a piece of wood by burning in lighted matchsticks near it? Why do you have to use a paper or kerosene oil start fire in wood or coal? Have you heard of forest fire? During extreme heat of summer at some place dry grass and catches fire from the grass. It spread to trees and very soon the whole forest is on fire. It is very difficult to control such as a fire. Thus, these experiences tell you that different substances catch fire at different temperature. The lowest temperature at which substance catches fire is called the ignition temperature. Can you tell why a matchstick does not catch fire on its own at a room temperature? Why does the matchstick start burning on the rubbing it on sight on the matchbox? The history of the matchbox is very old. More than 5,000 years ago, small piles of pine wood dipped in sulfur were used as matchsticks in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony, trisulfide, potassium charcoal, rand white phosphorus with some glue and starch was applied on the head of the match was suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of match. However, white phosphorus proved to the dangerous both for the workers involved in the manufacturing of matches and for the user. These days, the head of safety matches contains only antimony, trisulfide and potassium charcoal. The rubbings of surface has powered glass and little red phosphorus, which is less dangerous when the matches is struck against the rubbing surface. Some red phosphorus get converted into white phosphorus. This immediately react with potassium uh, charcoal in the matchstick. Had they produced enough heat, they ignite an antimony trisulfide and start a combustion. We find that combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. Have you ever seen cooking oil catching fire when a frying pan is kept from long on a burning stove? Kerosene oil and wood do not catch fire on their own at room temperature, but if kerosene oil is heated a little, it will be catches fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood? Does it mean that we need to take special care in storing kerosene oil? The following activities show that it is essential for substance to react ignition temperature to burn. Combustion. Be careful while handling burning candle. Make two paper cups by the folding a sheet of paper. Pour about 50 ml of the water in one of the cups. Heat both the cups separately with a candle. What do you observe? Water paper cups. What happens to the empty paper cups and what happens to the paper cup with the water? Does water in the cup become a hot? If we continue heating the cups, we can even boil water in the paper cup. Can you think of an explanation for this phenomenon? The heat supplied to the paper or cup is transferred to water by condensation. So, in the presence of water, the ignition temperature of paper is not reacted. Hence, it does not burn. The substance which have very low ignition temperature and can easily catches fire with the flame are called inflammable substance. Example of inflammable substance are petrol, alcohol, liquefied petroleum gas. Can you list some more inflammable substance? How do we control fire? You must have seen or heard of the fire breaking out in homes, shops, and factories. If you have seen such an accident, write a short description in your notebook and also share the experience with your classmate. Find out the telephone number of the fire service in your area if a fire break out in your house or in your neighborhood. The first thing to do the it is called the fire service. It is important that all of us know the telephone number to the fire service. Fire service. Does your city, town, and have a brigade station? When a fire brigade arrives, what does it do? It pours water on the fire. Water cools the combustible materials so that the temperature is brought below its ignition temperature. This prevents the fire from spreading. Water vapor also surround the combustible material, helping the cutting of the supply of air. So the air is extended. You have learned that there are three essential requirements for producing fire. Can you list these requirements? These are fuel or to supply oxygen and heat to raise the temperature of the fuel beyond the ignition temperature. Fire can be controlled by removing one or more these requirements. The job of a fire extinguisher is to cut off the supply of air and to bring down the temperatures of the fuel or both. Notice that the most common fire extinguisher is water, but water works only when things like wood and paper are on fire. If electrical equipment is on fire, water may conduct electricity and harms those trying to douse the fire. Water is also not suitable for fires involving oil and petrol. Do you recall that water is heavier than oil, so it sinks below the oil and oil keeps burning on the top? For fires involving electrical equipment and inflammable material like petrol, carbon dioxide, it is the best extinguisher. Carbon dioxide being the heavier than the oxygens cover the fire like a blanket. Since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of carbon dioxide is that in most cases it does not harm the electric equipment. How do we get the supply of carbon dioxide? It can be stored at high pressure as a liquid in cylindrical. In what form is LPG stored in cylinder? When released from the cylinder, carbon dioxide expands enormously in volume and cool downs. So it not only form a blanket around the fire, it also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Another way to get carbon dioxide is to release a lot of dry powder of chemicals like sodium bicarbonate, baking soda, or potassium bicarbonate. Near the fire, these chemicals give off carbon dioxide. In most cases, cannot be eliminated. If, for instance, a building catches fire, the whole building is the fuel. Types of combustion. Bring a burning matchsticks or gas. Light an air gas stove in the kitchen. Turn on the knob the gas stove. What you observe? We find that gas burn rapidly and produce heat and light. Such combustion is known as a rapid combustion. There are substances like phosphorus which burn in air at room temperature. The type of combustion in which a material suddenly bursts into the flame without the application of any apparent cause is called spontaneous combustion. Spontaneous combustion of coal dust has resulted in many distress fires in coal mines. Spontaneous forest fires are sometimes due to the heat of the sun and due lightning strike. However, the most forest fires are due to the carelessness of human beings. It is important for remember that the camper fires must be completely extinguished before leaving a forest after a picnic or a visit. We generally have a fireworks on festival days when a crackers is lighted. A sudden reactions take place with the evolution of heat, light, and sound. A large amount of gas formed in the reaction liberate. Such a reaction is called explosion. Explosion can also take a place if pressure is applied on the cracker. Flame. Observe an LPG flame. Can you tell the color of the flame? What is the color of the candle flame? Recall your experience of burning a magnesium ribbon in class 7th. If you do not have experience of burning the remaining items, table 4.2 can do that now. Colors of candle flame and the flame of kitchen stoves. Flames of kerosene lamp and candles. Record your observations and mention whether on burning the material forms of flame or not. Candle, magnesium, camphor, kerosene stove, charcoal. Structure of flame and activity. Light a candle's conscience. Be careful. Hold and 4-5 centimeter long thin glass tube with a pair of things and introduce it one and in the dark zone of non flickering candle flame. Bring a lightning matchsticks near the other end of the glass tube. Do you see a flame caught at this end of glass tube? After a while, if so, what is this that produces a flame? Notice that a wax near the heated wicks melt quickly. The substance which vaporized and during the burning give flame, for example, kerosene oil and molten wax, rise through the wick and are vaporized during the burning and from flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame in activity. 4.5. Could the vapors of wax coming out the glass tubes be the cause of the flame or produce? When the candle flame is steadily introduced, a clean glass table slide into the luminous zone of the flame. Hold it there with a pair of tongues for about 10 seconds. Then remove it. What do you observe? A circular blanket rings is formed on the glass plate slide. It indicates the depositions of unburnt carbon particles present in the luminous zone of the flame. Hold a thin long copper wire just inside the non-luminous zone of flame for about 30 seconds. Notice that the portion of the copper was just outside the flame get red hot. Does it indicate that the non-luminous zone of the flame is high? Temperature, in fact, this part of the flame is hottest part. Different zone of the candle flame. Innermost zone of unbrushed wax vapor black. Wax candle least hot. Middle zone of partial combustion yellow. Moderate hot. Hottest part and outer zone of complete combustion blue. Goldsmith below the outermost zone of flame with a metallic blowpipes for metallic gold and silver. Why do they use the outermost zone of the flame? What is the fuel? Recall that the source of heat energy for the domestic and industrial purpose are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. A good fuel is one of which readily available. It is a cheap. It burns easily in air and a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substance. There is probably no fuel that could be considered as the ideal fuel. We should look for a fuel which fulfill most of the requirement for a particle's use. Fuels differ in their cost. Some fuels are cheaper than others. Make a list of fuels familiar to you. Group them as solid, liquid, and gaseous fuels as table 4.3. Fuel efficiency. Suppose you water asked to boil a given quantity of water. Which fuel would you prefer? Give you reasons. You may take the help of your parents. Do these the three fuels produce the same amount of heat? The amount of heat energy produced in complete combustion of 1 kg of fuel is called the caloric values. The caloric value of fuel is expressed in a unit. Solid fuel, liquid fuel, gaseous fuels. called kilojoules per kg. Calorie values of some fuel are given in tables. Burning of fuels lead a harmful product. The increasing fuel consumption has harmful effect on the environment. Carbon fuels like wood, coal, petroleum release unburnt carbon. For centuries, wood was used as a domestic and industrial fuel, but now it has been replaced by the coal and other fuel like LPG in many rural parts of our country. People still wood as a fuel because of its easy availability and the low cost. However, burning of wood gives a lot of smoke, which is very harmful for human beings. It causes respiratory problem. Also, trees provide us with a useful substance which are lost when wood used as a fuel. Moreover, cutting of trees leads to deforestation, which is quite harmful to the environment, and you learn in class 7th. Particles. These fine particles are dangerous pollutants causing respiratory disease such as asthma. Incomplete combustion of these fuels given a carbon monoxide gas. It is a very poisonous gas. It is a dangerous to burn coal in a cold rooms. The carbon monoxide gas produced can kill presence of sleeping in that room. Oh, so that is why we are advised never to sleep in a room with a burning or smoldering coal fire on in it. Combustion of the most fuel release of carbon dioxide in environment. Increased concentrations of carbon dioxide in the air is believed to cause global warming. Global warming is a rise in temperature of the atmosphere of the earth. This result among other things in the melting of polar glaciers, which leads to rise in the sea level, causing flood in the coastal areas. Low-lying coastal area many even be permanently submerged underwater. Burning of coal and diesel release sulfur dioxide gas. It is extremely suffocating and the corrosive gas. Moreover, petrol engine give off gases oxide of nitrogen, oxide of sulfur, and nitrogen dissolve in rainwater and form acid. Such rain is called acid rain. It is a very harmful for crop, buildings, and soil. The use of diesel and petrol as a fuel in automobiles is being replaced by CNG, compressed natural gas, because CNG produce in very small amount of CNG is cleared fuel. Keyword acid and calorific values: combustion, deforestation, explosion, flame, fire extinction, fuel efficiency, global warming, ideal fuel, ignitions, temperatures, inflammable substance. What you have learned: the substances which burn in air are called a combustible. Oxygen air is essential for combustion. During the purpose of combustion, heat and light are given out. Ignition temperature is the lowest temperature at which a combustible substance catches fire. Inflammable substances have very low ignition temperature. Fire can Fire can be controlled by removing one or more requirement easily for the production fire. What is commonly used to control fire? Water cannot be used to control fires involving electrical equipments or oil. These are various types of combustion such as a rapid combustion, spontaneous combustion, explosions, etc. There are three different zones of flame: dark zone, luminous zone, and non-luminous zone. An ideal fuel is cheap, readily available, readily combustible, and easy to transport. It has high calorific value. It does not produce gas or reduce that pollute the environment. Fuel differ in the efficiency and cost. Fuel efficiency is expressed in the terms of its calorific value, which is expressed in a unit of kilojoule per kg. Unburned carbon particles in air are dangerous. Pollute causes respiratory problem. Incomplete combustion of fuel gives poisonous carbon monoxide gas. Increased percentage of carbon dioxide in air has been linked to the global warming. Oxide is sulfur and nitrogen produced by burning of coal, diesel, and petrol. Causes acid rain, which is harmful for crop, buildings, and soil. List conditions under which the combustion can take place. Fill in the blanks. Burning of wood and coal causes dash dash of air. A liquid fuel used in home is fuel must be heated to burnings.